What is going on, team? It is your friend Austin here with AP Space, and today we are going to develop the UART Interrupt Loopback software on the ATSAME70N21B microchip technology microcontroller. So, to begin, we are going to go to our schematic and we are going to review what our hardware is. So we have the microcontroller here, and then we'll just briefly scroll through the pages so that you guys have the hardware solution. And that is all of the pages. And what we really need to see is where is our UART4 pins routing to. So PD18 and PD19 are the pins on the microcontroller that we're using, and that's the RX and the TX on the microcontroller. So we're connected to the J5 D shell connector, and we have a loopback going from PD18 to PD19. So that's all I need to know with the hardware. And we need to go over to MPLabX and get started here. And how we begin here is we go to File, New Project, we go to Microchip Embedded, we go to Application Project, we go to Next, and then we select the 32-bit MCU SAM section, and then we go to ATSAME70N21B E70N21B there. And then we select our Atmail ICE programmer, and then we go to next. We go to the XC32V4.40 compiler. We go to next. We browse, and we are going to select our loopback 4 folder. Click into there, and we open that up, and then we go to, or we name this photon3 underscore v1 underscore UART4 interrupts loopback 4. And then that's what this project will be called, and we select finish, and it loads the new project. And then we can click the finish button there for the content download required, and the project will initialize for us. And what we need to configure initially is we need to go to the pin configurator. We can organize by ports, and then we can go to PD18. We can go to UART RxD4, and we can go to PD19 and go to UART4U TXD4. So we're using our RX4 and our TX4 on UART4 there. And that is all we need for the pin settings. We need to go to the NVIC configuration. And the NVIC is the nested vectored interrupt controller. In this context is what we're referring to. And we need to select the enable checkbox on UART4. So once we select the checkbox on UART4, we should be set there. And then we need to add the UART4 peripheral under device resources. And then click a new UART and add UART4, and then we have the peripheral library module here, and then the configuration options can just remain as default, so that is fine there. So we just close out of there, and then we generate the code. And that effectively creates a main.c file, and we need to select the main.c, and we need to copy and paste what we have from our initial project, and we need to copy and paste the blocks over. So we copy and paste block 1. Block 1's there. And copy and paste block 2 over. Copy and paste block 3 over. Block 3. Copy and put that in the while loop here. And then that's all we need for the main. And don't worry about the errors for now. We need to add the other files, which is our app1.h header file that we need to create. So how we are actually going to go about creating the header file and the C source file for this task is we're actually going to manually create the files. We're going to go to our Photon 3v1 folder. We're going to go to the Loopback 4, or no, excuse me, go to the Loopback 4. Go to the Loopback 4 folder. We select the source folder. Very important. We go into the source folder, and then we add a new text document. We call this app1, and it needs to be the C extension, and then we select yes on the changing the file extension, and we add another folder. We add another text document. This is also just simply app1, and this will be a header file. And we select yes on changing the file extension there, and then how we're going to add those is we're going to select header files, and then we'll right click on header files. So we go to add existing item, and then we need to go to the Loopback 4 folder. You need to go to source, and we need to add app1.h to the header files, and then we put that there. app1.h is there now, and then we click on source files, right click, add existing item, and then we select app1.c, and then we select. So the app1c file needs to be in source files, and the app1.h needs to be in header files. So once those are there, we copy and paste this over to app1.c, and then put that there, and then copy and paste this over as well. And that should be all we need. And then we go to main.c, and what may be very useful for you guys is to read where I was actually able to figure this out. So you need to look up the UART4 read callback register function, and that's listed in the classes, and it's the documentation of that is here within MPLabX IDE. UART4 read callback register is right here. If we go to the internet and just copy and paste that. Just microchip technology, click enter, and then go into the microchip website. And then this is where we found the code actually. So we just kind of read the documentation here and we use similar code to this example. So we're using the non-blocking mode, and this is the example we use. But what you really need is the read callback register and basically making a callback function that they call UART read event handler. And this is basically the callback function, right? So very important piece of information there. And in our code, to review what we're doing, we're defining arrays, we're importing an app1.h header file, we have counter variables. This is a callback function here. We're reading the data in the callback function, and we are calling the read callback register function to basically set our callback function. And then we wake up the interrupt by just sending 1 byte of data to array1 rx, then initializing a to 0. And then we're consistently sending the data string ap space 1 in the stored in the array 1 tx1 array. And we have a delay function, and then we're also calling app1 function 1, which is here in our app1.h function. So that should be all we need. And we can go to build now to make sure we have no errors. We build the main project and build successful. Very cool. Okay, so now we go to debug main project. So our microcontroller is programmed now. We go to watches. And we need to see that our array1 underscore rx1 array is not empty. So it's been running. Now the program has been running for a bit, and we would like to pause the microcontroller. So we paused the program basically, and everything worked. The code or the application we wrote has AP space 1 stored in the TX array, and we didn't have anything in the RX array initially. There's no data in there. And how we'd like to confirm that it works and works correctly is that all of the data matches what is in the TX array, and we effectively just sent AP space 1 approximately every second from the TX pin to the RX pin, and all of our data is there. And we also used an interrupt. There's to prove we indeed used an interrupt there. We don't have a receive function in the while loop, and we were able to make a callback function and then just keep reading data when we receive data to the receive port essentially. So that's all we have there. And then we also are just calling the app1 function1, which just runs the no operation function. And that exercise was just to show you guys how to create supporting header files and C source files without getting any errors in MPLABX. And that's how you do it on a ATSAME70 microcontroller. And you guys all have a wonderful day.